introduction. My name is Hendrik, and my supervisor is Aivo Kolde, and our group is the research group of health informatics. And this here is a snapshot of our beautiful family. And what we largely do is, we believe that data-informed and evidence-based decisions make healthcare more efficient, patient-friendly, and cost-effective. And so we generate that evidence largely by conducting epidemiological studies and data analytics. So kind of like population-scale statistical studies related to like the prevalence of diseases and such. And for this, we have a lot of textual data, mostly generated by the interaction of the patient with the healthcare system. So what you can sort of intuitively think about, for example, is that when you go to a doctor and afterwards you look at your patient portal, for example, then like this sort of information is what we have at our disposal. And a large portion of that data is quite well structured, which makes it really convenient to use for any data analytics. So, for example, tabular data about I don't know, the age, height, or weight of the patient. It's just numbers, and mostly probably because when the doctors have to input this information, then they are only allowed to type integers or floats. But a lot of this information is also in the form of text. So again, if you were to look at the text that is generated from you visiting a doctor at the patient portal, then it's even to like you personally, it could be really hard to understand sometimes. And so one of the things you have to do to sort of get value from this information is you have to extract what's important to you. And a really naive way, or like a simple way that actually sometimes could be the best way to approach this is, for example, using regular expressions. So if we have like an example text over here, see if we can do this. Oh yeah, there we go. Then let's say that we want to get like the ATC code out of this text, which is that red thing over there. It's sort of a unique ID related to the drug. Then what we might go for is we might describe the pattern of the code, and if it matches, then okay, we have it. Or if we want like the active ingredient or the drug name there, then like the list of drugs or the like ingredients there are pretty fixed. They might like new stuff might come along, but then we can just update the list, but it's a pretty easy way to get this. And how we might go by like developing or creating the regex patterns is just looking at the data and trying to see if we can like match what we need to find. So for example, Gleason is in the context of prostate cancer is something that describes like kind of how bad or what state the cancer cells are in. So it would be a number from like 1 to 10, let's say. So it's a pretty simple approach, okay? We just need to find Gleason from the text and the digit that follows it. But there might be more complicated nuances that come from the fact that the medical domain is quite specific in a sense that, for example, doctors use a lot of shorthand, and they have like these sort of ways of how they write information, which is like really intuitive to them, but it's kind of hard to understand if you're not very familiar with the domain itself. So we might have to like add a few new phrases there, or like the shorter versions or abbreviations. And then these might also like hit the targets that we don't actually want to get. So it's quite problematic. And another method that is quite like the, let's say, most reasonable one to some extent, or in some contexts, is using like transformers. So we need, in order to like train these models, we need to have training data in the form of text that's like been annotated. So in here, for example, we have like annotations for the TNM code and the date. And when we have the annotations, then with these we can train a model to annotate it from the text. So we would like not need to develop the regex, but instead we'd need to have annotated data. But this is kind of a problem in a sense that in Estonia we don't have a lot of annotated data, like virtually zero, whereas other languages might be more rich with this. Now, for any non-medical problem, if we want annotated data, then we have a really efficient pipeline in place for this. So we have a highly respected member of our group that targets down preferably linguistic students and asks them to annotate data for us in exchange for money. And this kind of works in any other domain where data isn't so sensitive, but since we're dealing with the medical domain, then we can't really give any random student the data. It has to be, it's like a more complicated process that involves consent and such important things. So this is an approach that we sadly cannot use. So we thought, okay, what if we tried using ChatGPT to annotate data? What sort of quality would we expect from it, and how would the process look like? Is it something that's even feasible? So the initial thought was, okay, we take data from the clinical corpus, so whatever we have, we give it to ChatGPT, and we ask it to annotate whatever annotation classes we're looking for, and just use this as training data for like a downstream model. What we sort of so far really have found to be efficient, for example, is a multilingual Roberta. So the advantage of that is that we can use other languages to help us as well. All right, but since the data is sensitive, we can't really send it to third-party applications, and we have to be really careful with this. So one of the workarounds for this was Mihkel from our group pre-trained a GPT-2 model to generate synthetic data. So sort of a similar solution in two places here. So what this allows us to do is to generate synthetic texts. So we can give it, for example, what sort of text we're looking for, what age group do we want the text to be generated from, what gender and what disease. And based on this, it will sort of keep generating text that's supposed to imitate then the anamnesis of a young woman with breast cancer in this context. And then we give this text to ChatGPT and it attempts to annotate it. So this kind of means we have to sort of look for good prompts to get the best results. And one of the things that I ended up using right now is a weird role-playing with where I kind of tell it that it is a highly intelligent and accurate medical domain named entity recognition system. And the output that it's allowed to give us is only JSON. And all the description, so in this context, we're asking it for the drug, procedure, family history, or breastfeeding. So we give it quite, in relatively little information of what we're actually looking for, right? In this case, we're just telling it procedure named entity and hoping that it sort of understands from the context. And then we give it the text. And this is sort of what the output from this prompt might look like, where it actually does give us the JSON output from the text. And then here comes the question of sort of processing this in order to convert it into training data. So you have to get it from the text. And so far, I haven't really had any problems with it not returning me a JSON. Very rarely, it sort of tries to invent weird entities that actually don't exist, or has text in it that actually isn't found in the real text. And before, when I gave it the text, one of the things that I had to do was I had to manually add a period at the end of every sentence, because sometimes even to this prompt, it would sort of just keep generating the random text because it thought that the sentence isn't over, I need to continue. And then after we've converted the JSONs that it gives to us and parsed it to training data, then we can train the downstream model for the task and start using it on our own real data, for which we have pipelines in place. So one of the experiments that I carried through to sort of help us understand the effectiveness of the pipeline, or where we might have some sort of shortcomings, was we generated around 1,000, so 960 texts, half of which were anamnesis and half of which were procedures, with the hopes that these text types contain the information that we're looking for. We went for all age groups for women who were diagnosed with breast tumor, because this was sort of aligned with our other interests in another project. And then we tried annotating it initially with GPT 3.5 Turbo, because for a long time we didn't have access to 4, and then with 4 once it came out. And the classes that we were looking for were drugs, so sort of just medication name, procedure, which we left quite ambiguous, family history, so sort of any mentions of a relative of the patient having any disease, and then breastfeeding. And for validation, we had a person who was a medical domain expert annotate some real data. So again, health procedure and health anamnesis for the same classes. And the idea was to sort of use this to see if how accurate the resulting model is. First, if we look at the entities in the annotations compared to the test set, this sort of one important aspect here, for example, is to help us see if the distribution of the entities is somewhat similar. So the test set was about 3 times smaller than the synthetic data that we generated. For example, there's 2 times less drugs, so there's probably more drugs in the real data than were annotated or generated by the synthetic model. One problem here that arose was the fact that family history had a really, really low amount of entities in the synthetically generated text. And the reason for this is that family history generally doesn't pop up very often. So if we wanted more entities, then we now know to sort of give it or target it to generate family history more specifically. And I think there were 0 cases of breastfeeding that came out from this. So we were pretty much left with drug and procedure. And the cost of about 1,000 annotated texts with the GPT 3.5 was about $1, which is virtually nothing. With the GPT 4, it was $15, so somewhat considerable already. And one really interesting aspect to think about here is obviously we didn't measure it, but the humans have a sort of price for annotating data as well, at least if you're not a student. And it would be interesting to sort of compare this with GPT performance. And so the results from this, because there was too few data for family history, the model really didn't train it. But the drug and procedure we had some indications with. So with the GPT-4, the results for finding drugs from text were not that horrible. There's a cheat sheet on the right for what the precision recall and F1 score is, but I guess intuitively you could think about precision is that if the model makes 100 guesses, then in the context of GPT-4's recall, then 75% of those guesses would land the spot. And in the case of recall, it's if there were 100 predictions or 100 entities, then how many of those would they get? So, for example, 73% in this case would be hit, and 27% would be missed, so the model didn't get them. So, looking at these results in the context of drug, it's not the worst, it kind of works. I guess mainly I would imagine that it's an intuitively easy task to understand. You don't have to describe it very much to GPT, whereas procedure is kind of weird. And in the context of asking humans to annotate data, you have these annotation guidelines that are sometimes tens of pages of documents just to describe what you mean by procedure. And one interesting aspect for the future is to sort of give better instructions or better prompting in general, but actual annotation guidelines to ChatGPT, and the same you would give to a human, for example. Yeah, and the results for procedure were pretty horrible. They're sort of by nature very different. They appear differently in text as well, in the context that drug is usually 1 or 2 words to describe the name of the drug, whereas procedure could be a whole sentence of patient was given some sort of test with pictures, blah, 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 something like that. Yeah. Well, one of the sort of key takeaways, in my opinion, from this sort of approach is the fact that it's a process that involves multiple steps that could be improved. So first off, generating the synthetic data. What sort of models you use for that, how you do the prompting there to sort of get the data that you actually want to annotate. So we missed breastfeeding and family history because there weren't enough cases of them in the text, but if we were like smarter in generating them, then it might have ended better. Then the whole idea of prompt engineering is still kind of like seems silly to me, that I have to role play with ChatGPT to get like a better model at the end, which is crazy. And then even the final downstream model. So as I mentioned, the model that we use for annotating is multilingual. So if we have data from the same task, but in other languages, then we can also add these to the training data and improve the results considerably. And then if we have any sort of human annotated data at all, then other researchers shown that it's like really effective at making the model a lot better. But yeah, there are a lot of points that can be improved here, and since this is kind of like an intermediate of result of like where we are or what we're messing around with, then there's even more to think about ourselves. But yeah, thank you very much.
Thank you. Please.
Thank you very much for this interesting talk. I understand that it's still maybe in the middle of the project, right, or in the beginning stage.
Mm-hmm.
And can you show the slide with the recall and precision numbers? So I was just wondering, okay, this is not yet good, but what would be good enough for the final purpose? I mean, do you know already what you want to achieve?
We have I mean, the best reference that I found, for example, is like the same type of models on English to find the same entities. And for reference, like drugs seem to be around 0.9 F1. Like it's a pretty solvable or like somewhat easy task. So that's kind of like north of 0.9. And the procedure being a bit trickier should still be like somewhere around 0.8.
And 0.9 is good enough for the purpose?
Of using it like actively to like enrich in real data.
Okay. I think there is a big difference whether you do statistical analysis of the corpus versus make the life dependent decisions on you individually. Yeah, but this is the statistical.
Yeah, it's sort of population based.
Thank you very much. Very interesting talk. May I ask about the procedure? So you generated fake data basically with GPT 3.5.
We generated fake data with GPT-2.
Okay, and then you fed it to GPT 3.5 and 4.
Yeah.
Okay, so the fake data was the base data, the database for the study. That's okay. Yeah. Okay, and the expert who did the human annotations, he annotated the fake data. Yes.
The expert annotated real data.
Okay. So why didn't the expert annotate the fake data? Because if you want to compare understand the accuracy of the GPT 3.5 and 4, then you need to compare it to the same data. Yeah,
that's a good question. So I think the difference here is pretty much, do we want to precisely study the accuracy of the annotations of the GPT 3.5, or do we want to have an idea of the whole pipeline as a whole? So our idea was that if following this pipeline, what are the actual results on the real data at the end? So we could take any intermediate step in the process and have our own analysis of that in particular, but we wanted to sort of glimpse that is this approach even worth going into.
Okay, to kind of poke which is the right method and how to go. Okay, well, thank you very much, very interesting work, and my suggestion for the future work would be also to include maybe students t-test or an OVA that would give the possibility to calculate the p-value and so forth, which would make such work very convincing.
Okay, thank you.
Thank you very much.
I guess my question is in the same ballpark. How can you trust synthetic data? Because as a non-expert, you might think this makes perfect sense, but to a doctor maybe, or biologically or medically, this synthetic data might not make sense. So you have to check for that.
What do you mean make sense?
If you generate synthetic data, right, it might generate data that actually, like medically, does not make sense, right? It might make up a scenario that in reality does not exist or something.
I'm not a big fan personally of stuff making sense or trust, but I think what's important in this context is, does it work? And if we validate that on real data and like sort of find out that, I guess by looking at how effective the final downstream model is on real data, we can get a glimpse or like that the synthetic data generated is at least good enough to actually train these models on it, right? And if that works, we're like happy. We're not going to like do anything else with the synthetic data. It's sort of a midway step in order to help us get the final tools.
Yeah, I guess if it works, then it works, yeah.
Yeah.
Okay, thanks.
Anybody?
Is there any concern with using the synthetic data and sending it to GPT that it might generate features of actual people and like have too little training data available for the GPT-2 model?
Yeah, so it's I haven't found anything super good in like in a way of like how do I verify that the synthetic data I generate is different enough that like no actual like personal information comes out of that. If you have any ideas on that, I'd love to discuss it. For now, I think we looked at the longest common substring, pretty much just to see if like any like specific substring occurs in the actual original data that it does in the synthetic. But other than that, we can look over, see that there are no names, and hope that like everything else is good enough.
It is subsequence, not substring. Last night we talked about that, if we are talking about the same thing.
Okay, thank you.
There's a big difference between substring and subsequence.
Right.
Tell me, how do you think ChatGPT overall in the training data can have these personal medical data in the first place? Does ChatGPT-4 get trained on medical data?
Yeah, I think it most likely...
Some hospital donated that, or what is the data that could be there?
I think, like, to some extent, I think it's emergent, in a sense that, like, if it understands what procedures are based on, like, just general medical text, then it could sort of derive on how they're represented in that text. But I'm sure that it has access to, like, some even very specific task-related data, like, somewhere.
Okay. Scary. We have exhausted all the questions, and thank you again.
Thank you.